Cats, this is 4.4 trigonomic functions of any angle. In the past, we really dealt mostly with special angles, and we are still going to have some cases where we'll be using special angles. We even have an example of that today. But often now, it may not be a special angle. It may be an angle that is not one of our familiar angles from our chart. Please make sure, I want to see in your notes tomorrow that you've written your chart down 3 times. I know that's a lot, but I want you to write it 3 times, and preferably 3 times from memory. So the other thing you want to do is I've noted right here to make sure that you've set up and completed the solving of problems 63 through 66 on 309. Those are the ones we wrote on the board today, and I want to see those as part of your notes as well. So as soon as you do those, then go ahead and write your chart out, your 30, 60, 45, cosine, sine, tangent chart out 3 times, just so you make sure you really know those and don't lose that, because again, that is going to be used throughout all of our trig units. Alright, the next thing we're going to do is we're going to talk a little bit today about, and I'm going to work through some examples for you on if the angle that we're dealing with is not a special angle, and how you know that and what to do with it. I'm going to first give you, we're going to still be back in a unit circle. And I'm going to go through here, and we're going to pretend like there's a circle there. You can understand that. In the past, when I said unit circle, it meant that the radius was a length of 1. I want to talk about our identities that have to do with that. So we're going to draw a right triangle here. But we're going to pretend for a minute we don't know if this is a unit circle. In other words, I don't really know if this is a unit of 1. So I'm going to call it R for radius. We know across from R is Y. We know adjacent or the opposite side or adjacent to our reference angle is x. We also know x is our cosine value and y is our sine value. So just to go over our identities one more time, we already did this in one way yesterday. This is just a different view of it. Sine theta. You know that is opposite over hypotenuse. And if you use that theory, that would be y over r in this case. Y over r. And I'm just trying to help you understand the different views of this. So y over r. We know cosine theta is adjacent over hypotenuse, and in this particular case that would be x over r, because this may not be a unit circle, so that radius may not be always 1. For tangent theta, we know that is opposite over adjacent. So in this case, tan then would be y over x. And we've talked about that for quite a while, so you do know that one. Let's go ahead and take care of the reciprocals. So if we take care of the reciprocals, in this case we would have cosecant theta, and that would be r over y. We have secant theta, and that would be r over x. And we would have cotan theta, and that would be x over y. That one you've been familiar with. And that's just kind of reviewing a little bit. Let's take a look at what we do now using our concept of SOHCAHTOA, and we're not in a unit circle, and we're not talking about special angles anymore, all the time at least, in the next example or so. And let's take a look at what we do. Alright, so this example, we're going to say, this is example 1 for us. We're going to let 4, -3 be a point on the terminal side of theta. It's a point on the terminal side of theta. So let's take a look at what we do. So let's draw our axis, and let's just plot that point. That point, we would go a distance of 4, and then we want to go -3, and it's a point right there. We're going to go ahead and draw our right triangle, and we're going to label this inside angle our reference angle. We talked about that today. We now know this is 4 and this is -3. What if I wanted to find the cosine of theta, the sine of theta, and the tan of theta? I could use the Pythagorean theorem to find my radius. I don't know what that radius length is. You can't say that sine is -3 because it's not necessarily a radius of 1 in this case. Before, when it was a unit circle, the radius was always 1, and we could have said, well, we couldn't have said 3. 3 would have to be, it would have to have been smaller than 1 in a unit circle. All right, so let's use Pythagorean theorem. So we would take 4 squared plus -3 squared equals our radius squared. That would be 16 plus 9 equals radius squared. That's 25 equals radius squared. Take the square root, and remember the radius always has to be positive, so that would be 5. You would also know that this is a 3, 4, 5 triplet triangle from geometry, and you probably already know that. Now we have a right triangle. We just use SOHCAHTOA again. Cosine we know is adjacent over hypotenuse. Sine is opposite over hypotenuse. Tan is opposite over adjacent. And we use our right triangle from our reference point. So cosine would be 4 over 5. Sine would be negative 3 over 4. And tan would be negative 3/4. And go Bearcats. Not too bad. All right, let's look at another example. We're giving our information just a little different format. This time we're going to be given that cosine, so this is example 2, just different types of information. We're going to be given that cosine theta is equal to 3 over 5. We're going to be told that tan theta is less than 0. So first thing we have to do is figure out what quadrant we're in. What quadrant we're in. That's important because that means things are positive or negative depending on the quadrant. Since cosine is 3/5, this is a positive value, then cosine is positive. All right, we're going to use our little all surfers to California. And remember, positive cosine would be in the first quadrant and the fourth quadrant. And we're going to use this little check mark system. We're going to be using this for a long time, so you really want to use this as your practice for this. If this says tan theta is less than 0, that would mean tan would have to be negative. Again, using all surfers to California, tangent is positive in the first and the third, so tan would be negative in the second and the fourth. Here's where our 2 check marks are. That's our Go Bearcat quadrant, and we're going to draw our right triangle in this quadrant right here. And our reference angle, of course, is right there. Now, going back to the information we have right here. Cosine is is adjacent over hypotenuse. So cosine, or our x value would be 3. Our hypotenuse, or our radius in this case, would be 5. Again, this is a 3, 4, 5 triangle. This would be 4, but be very careful. This would have to be a negative 4 because you're in the fourth quadrant. Then you could use SOHCAHTOA to solve any of the 6 trig functions that you wanted to. We'll just pick one. Well, let's pick cotan. This is one that we haven't done in a while. Cotan, you know, is not opposite over adjacent, but adjacent over opposite. So cotan theta would be adjacent, which would be 3, over opposite, which would be negative 4. So negative 3/4 would be cotan. And you could do that for any of the 6 functions. All right, let's take a look at another example. Now I want to talk a minute about reference angles. Reference angles. And we've talked about them before. This is going to seem somewhat familiar. So about reference angles. Let's just take a look at a couple of reference angles. We're going to do 2 examples, so we'll call this example 3 and example 4. So in the first example, we're going to be given an initial angle of 125. In example 4, we're going to be given an initial angle of 227. All right. The first thing we're going to do is we're going to draw our axis. And this is our initial rotation. So we would rotate 125 degrees. 125 degrees would put us in this quadrant. We're going to draw our angle. That's 125 degrees. We're going to draw down to the x-axis, and we know inside here is our reference angle, and that's what we want to know. Well, this is 180 degrees. So 180 degrees minus 125 degrees, I believe, is 55 degrees. So our reference angle is 55 degrees. And how we note that is we're going to say reference angle, that's got a little asterisk by it, that makes that makes the reader know that it's a reference angle, and that's at 55 degrees. And there we go. In example 4, we're going to think of our initial rotation as 227 degrees. So it'll be right here. We're going to draw our triangle, our angle, and this is 227 degrees. We're going to draw up to the x-axis. Please note, it's inside that your reference angle is. I want to know what that is. Well, this is 180. and we've rotated from 180, and we keep rotating down to 227. So this time we could take 227 and subtract 180 to find our reference angle. Okay, and when we do that, I believe we're going to get 47 degrees. Okay, so this would be 47 degrees. So our reference angle is 47 degrees. We can put that little asterisk on our reference angle if we would want. So up here when we have our original angle is theta is 227, our reference theta, our reference angle is 47 degrees. Okay, go Bearcats. All right, I think we've got a couple more examples and then we're almost there. And we're almost there. All right, next we're going to use this concept of reference angles, and we're going to use our chart. We're back on our chart again. So sometimes it's back to knowing your unit circle again. So I'm going to ask that you also, in your notes tonight, create the unit circle. Oops. Or review your green card. Okay, and you could review your green card. You've written your chart down 3 times so you can go back and refer to your chart in a minute. In this example, we're going to be asked to evaluate sine 210 degrees. When we're asked to evaluate are those values the square root of 3 over 2, the 1/2, or the SOHCAHTOA values, depending on if you are familiar with the angle or not. So let's take a look at 210 degrees, where that would be. 210 degrees would be a rotation past 180. Draw our right triangle. And our theta would be right in here. And if this is 210 degrees, and you've got to go back to 80, how far is that? Or from 180 to 210 is 30 degrees. So your reference angle is 30 degrees. So all we have to do is think of our chart at 30 degrees, which is at pi over 6. And if you remember, we have cosine, sine, and tan. And if you've already written this on the other part of your paper, take a look at it. At 30 degrees, cosine is the square root of 3 over 2, sine is 1/2, and tan is the square root of 3 over 3. Something you just have to know. Now, we've got to look at our all surfers to California. In the third quadrant, the sine value is negative because tan is positive. So we know when we evaluate sine at 210 degrees, it's going to be a negative number. And then we think of our chart, and we know the sine value is 1/2, so negative 1/2. This was a lot like that one section on our last test where we actually redid that section. I gave you a chance to rework that section a day or so later after we went over it. This is very similar to that. This works off the chart because the reference angle was 30 degrees. If the reference angle is not 30 degrees, you'll have to convert to SOHCAHTOA to help you solve your, or to evaluate. All right, I've got, I believe, one more, and then we will be done. All right, in this case, they're going to tell you to let theta be an angle in the third quadrant. So we're in quadrant 3. And the other piece of information is that cosine theta is equal to negative 1/4. All right, so the first thing I'm going to do is draw a picture every time. I'm in quadrant 3. I'm drawing a triangle in quadrant 3. I know this is my theta. And it says cosine is negative 1/4. All right, negative 1/4 does not remind me of something that comes off my chart. So I have to revert back to cosine is adjacent over hypotenuse. So if this is my theta, adjacent to me would be 1, and the hypotenuse would be 4. This is negative 1/4. Hypotenuse is always positive. This would be a negative 1. Plus, you know that we're talking about this order pair, negative 1 and then a y value. This is in the third quadrant. Your x value would be negative. Your cosine value is your x. So we would have to finish solving by Pythagorean theorem. So we would have this leg squared, so negative 1 squared, plus the missing leg squared, which you're going to refer to as your y value. So y squared equals 4 squared. So we have 1 plus y squared equals 16. We would subtract the 1 and get y squared equals 16. We would square root both sides and we would get y is equal to either positive or negative 4. Positive or negative 4, depending on the quadrant you're in. So I'm going to say this is 4. Uh-oh, I made a big boo-boo. It's not 4. We got to subtract 1. So it would be 15, square root of 15. Sorry. So y is the square root of 15. What made me think that it couldn't be right? Well, what made me think is the hypotenuse in a leg cannot be the same thing. The hypotenuse is always the largest side. So I had to pause and realize my mistake. Let me erase this real quick. And then we'll go back and finish up our problem. Sorry about that. All right, so this is actually the square root of 15, but it's going to be negative square roots of 15. And again, it could be positive or negative depending on the quadrant you are in. All right, so I want the sine of theta. Give it that information. So the sine value would be opposite over hypotenuse, which would be negative square root of 15 over 4. So there would be one of my answers. And then let's also do the tan of theta. Tan is opposite over adjacent. So opposite would be negative square root of 15 over adjacent, which is negative 1. Plus, what do we know? All surfers to California, tan is positive in the third quadrant, and that's a negative over a negative, making it positive square root of 15, and that would be my tan value. That would be my sine value, and we know sine is negative, so that makes sense. All right, that's really it. Some of this is going to feel fairly familiar because we're still using SOHCAHTOA, we're using our chart, we're using our unit circle, but it's all going to start to come together. I hope you have a great night. Please don't forget the application problems we set up in class to finish those and to write your chart down 3 times. I'll be looking for that in your notes. And we'll be ready to work. I'll have the work on the board. It'll be the work on your calendar when you come in tomorrow so you can just get started and have your notes out. And I'll come by for points for your test. All right, have a great night. Good night, Bearcats.